All right, so our last section for this week is going to be section 8.1. Okay, we're just going to look at the first part of it. Okay, and it's called the law of sines. Okay. Basically, in this section, all we have to do is figure out how big each side is in a triangle and how big each angle is. That's it. Okay, we've already done this. Okay. When we did it with triangles that had a right angle. All right. The only difference is this time we're going to do it with triangles that do not have a right angle. Okay, so if you have a triangle and none of the angles are 90 degrees, that's called an oblique triangle. There's really two types of oblique triangles you could have. You could have an acute triangle, where all the angles are less than 90. An specific example would be like an equilateral, 60, 60, 60. Or you could have an obtuse triangle. That's where one angle is bigger than 90. Could you have two angles bigger than 90 in a triangle? No. No, how come?
It has to be 100 degrees, like 2 more than 90. 90 plus 90 is 180, so you already be over.
Yeah. Okay, if you had two angles bigger than 90, it would add up to more than 180. Right? Because there's no 90-degree angle, the side that would be across from the 90 is not going to be in any of these problems. What do we call the side that's across from the 90? The hypotenuse. Okay, so these triangles that we're going to look at don't have a hypotenuse. Okay, if they don't have a hypotenuse, a couple things we can't do. We can't use the Pythagorean theorem, okay, because Pythagorean theorem, you have to have a hypotenuse. And we also can't use SOHCAHTOA. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse. We don't have a hypotenuse. Okay, so we can't use that either. Okay, what we can still do, though, is use the fact that all the angles add up to 180. Okay, that is still true. Okay, here's our diagram for solving oblique triangles. Okay, the sides are still labeled ABC. Okay, does anybody remember we've used this Greek letter before? It's across from A. Alpha. Yep. And how about the Greek letter across from B? Beta. Okay, so that's the same. The only thing that's different is now I've given a name to what used to be the right angle. Okay, that Greek letter is called gamma. Okay, and when we make our diagrams, they don't have to be to scale. Okay, the only important thing in the diagram is that you always put A across from alpha, put B across from beta, and put C across from gamma. If you want to draw it as an equilateral triangle, it doesn't matter. Okay, the picture is just to help us see what is across from what. It's not necessarily to scale. All right, so there's three types of problems that the law of sines can help us to solve. Okay, and it depends on what information you're given, whether or not you can use this law. Okay? You can use the law of sines if they ask you to solve a problem with two angles given and one side given. Okay? And there's actually two ways they could do that. They could give you two angles and the side that connects them. Okay, I'll draw a picture. Or they could give you two angles and a side that doesn't connect them. Maybe I'll just sketch it. Make a new page. Okay, so here's an example of angle side angle. Okay, they'd have to give me an angle, a side, and another angle. This time, the side that I know is between the two angles. It connects them. Okay, so that would be a diagram of angle, side, angle. And to finish finding everything else, you could use law of sines. Okay, here's side angle. they would give me a side, an angle, and an angle. So they've still given me the same information, 2 angles and a side. This time the side they gave me is not the one that connects the 2 angles. Okay? They could have given me the side that I labeled, or they could have given me the side on top. Either way, this would be a side angle angle. Okay, and the last type that you can use law of sines to solve is a side-side angle. Okay, that's where they would give me a side, another side, and the angle they give me is not between the 2 sides. So it can't be this one down in the bottom left here. It'd have to be one of the other ones. Like that. Okay, so side, side, and an angle, not between the 2 sides. Okay, so any questions on the 3 types of problems you can solve with law of sines? We're going to go through how to do it, but that's just what you use it for. Okay, there's 2 types I did not mention. Yep, side, 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 and side, angle, side. These 2 problems cannot be done with law of sines. They're going to be something we do the following week. Any guess what LOC stands for? That's law of cosines. Okay? So the law of sines, between the law of sines and the law of cosines, you can solve every type of problem. Okay, but these 2, that's going to be next week. Okay. Now, some people say, well, what about angle, angle, angle? You could never solve an angle, angle, angle problem. Okay. Think if I said to you, I have an equilateral triangle. All the angles are 60. Do you know how big each side is? Yeah, the sides can be any length as long as they're all the same. Could be 2, 2, 2, 10, 10, 10. We don't know. Okay, so you can't solve angle, angle, angle. That doesn't exist. Okay, so as I just said, to solve angle, side, angle, or side, side, angle, we're going to use the law of sines. And you only use it for these 3 types. All right, so next we're going to look at where the law of sines comes from. Okay, and the law of sines is really uses what we know about right triangles to figure out problems about triangles that are not right angles. Okay, so I'm going to draw a triangle, and it's not going to be a right triangle, but then somehow I'm going to split it in half and make it into 2 right triangles. Has everybody got that? All right. So here's my triangle. I don't need to label everything here. I only need to label a couple sides. So let's call this side A. Let's call this side B. And then what do I always have to put across from A? Alpha. And across from B? Beta. Okay, now what I'm going to do is draw a line straight down from the top, perpendicular to the bottom side. Okay, and that's the height of my triangle. We'll call that H. Okay, by drawing in the height, what did I just create? I just created two triangles. What kind of triangles?
Right.
2 right triangles. Okay, what I'm going to do is I'm going to cover up the right-hand side, and we're just going to look at the left one. Okay, we're going to focus on the left, and then we'll come back and look at the right in a second. All right. All right, so it's focusing on that triangle. I want to use a trig function that involves opposite and hypotenuse. Okay, out of sine, cosine, and tangent, which one involves opposite and hypotenuse. Sine. Yep. So I'm going to write down sine. What's my angle in this triangle that's labeled? Oh yeah, so we have the 90, but what angle have I given a name to?
Oh.
Alpha, yeah. So sine of alpha equals, what side is opposite alpha? H over the hypotenuse is B. So H here is not hypotenuse, that could be confusing. H is the height. Okay, and my last step, I want to get H by itself. So how would you move B to the other side? Multiply by B. Okay, so now we have a formula for the height. It's B times the sine of alpha. Any questions on finding the formula for the height? All right, now I'm going to cover up the left-hand triangle, and I'm going to do exactly the same thing on the right. Okay, I, again, want to come up with a formula for that height. Okay, which trig function, again, involves opposite and hypotenuse? Sine. What's the angle that I've labeled in this diagram? Beta. And what's the side opposite beta? Height over A. Okay, and my last step again is I want to get H by itself. So how do we move A to the other side? Multiply by A. So now I have another formula to find the height. A sine beta. Any questions on that? So now, if the box on the left is equal to the height, and the box on the right is also equal to the height, that means something else. What else does that mean? Box 1 equals the height, and box 2 equals the height. Yep.
Congruent?
What's the same thing?
The two triangles, just different scale.
No, we don't know that they're congruent. We don't know they're congruent, but I mean, we know the height's the same in each triangle. That we know. But box 1 equals the height, box 2 equals the height. Sine of alpha and sine of beta would be the same? Not quite. I have the same amount of money as John. I have the same amount of money as Matt. What else do you know?
How much money did Matt John have?
You don't know how much money they have, but you know they have the same, right? Because they each have the same amount of money as me. They must have the same amount of money as each other. So if box 1 is the same as the height and box 2 is the same as the height, what do you know about box 1 and box 2? They're equal. Box 1 and box 2 are the same thing. So B sine alpha equals A sine beta. Okay, so that's what I was looking for. B sine alpha equals A sine beta. Okay. Now what I'd like to do is put the B on the side with the beta, put the A on the side with the alpha. So what could I divide each side by to move the A to the left and also move the B to the right? Divide both sides by AB. That's going to cancel the B on the left. That's going to cancel the A on the right. And that basically gives us the law of sines. Sine of alpha over A equals sine of beta over B. Okay, and there's a third part to the law, which we didn't prove, but based on the pattern, does anybody think they know what the third fraction would be? Sine of alpha over A, sine of beta over B.
Sine of C over gamma. Sine of gamma over C.
Sine of gamma over C. Okay, we didn't prove the third part. To do that, I'd have to draw the same triangle again, but instead of drawing the height from the top, I could draw it from a different side. Okay, so we're not going to go through the proof of the third part. Just repeats what we already did. Okay, so this is your law of sines. When you use the law of sines, you never use all three fractions at once. You're either going to use the first two, the last two, or the first part and the last part. Okay, so we're going to use that to help us. And we're also going to use the fact that all the angles in a triangle add up to 180. Okay, so any questions on that? All right, so we'll spend the rest of the time probably just going through 3 examples. One of each type that you can do with law of sines. Okay, we'll do one angle, side angle, one side angle, angle, and one side, side angle.
Can you go back to that one?
This?
Yeah, so the finished problem.
So the final formula,
Yeah.
right there. Okay, so again, what's in this box is called the law of sines. All right, so first thing you have to do when you're solving one of these problems is you have to figure out, is this problem something I should use law of sines for? Or is this something I should use law of cosines for? Okay, of course, all the problems today are going to be law of sines. But on the next test, you're going to have problems, bless you, that you have to decide which law to use. All right, so in order to decide that, the easiest thing to do is make a picture. Okay, so as we draw it, just make sure you put A, wherever you put it, put that across from alpha. Put B across from beta. And C across from gamma. Okay. Based on what I just drew, which one of the 3 types of triangles is this one?
Side angle, angle.
Yep, this is a side angle, angle. Or if you said angle, angle, side, it's the same thing. All right. I think I worded it, what did I word it as? I did side, angle, angle. Okay. So I'll write it that way. That is one of the 3 types you use law of sines for. Okay. So now I know, okay, use law of sines. Okay. The next step, I like to put all this stuff in a table. And the table is just to organize the information. So A is 4. B I don't know, so I'm going to put a box around it. C I don't know, so I'll put a box around that. Alpha is 20. Beta, 60. Gamma, I don't know. Where I have the 3 boxes, those are the 3 answers I need to find. So when I said you're going to have some problems on the test that have 3 answers, each one of these I'm going to count as a separate problem. Beta, C, and gamma. Okay, so you can get partial credit for each one you get right or wrong.
So, wouldn't this be like a 3, 4, 5, or you can't tell until you do it?
Well, that would mean if it was a right triangle. 3, 4, 5 is always a right triangle. Let's see what gamma is. Okay, we can find gamma right away. Okay, and we don't even need law of sines for that. Okay, what's gamma going to be? It's going to be 100 degrees. Okay, because all the angles have to add up to 180. Now, if I can avoid it, should I use gamma to find other things in this problem? No. If I can avoid using gamma, I will. Because if gamma is wrong and I use it, then other things are wrong. Okay. Unfortunately, when we do the law of sines, most of the time you have to use something you found to find something else. In this problem, you have to use gamma to find C. There's no way around it. So if you make a mistake with gamma, then C is wrong. But you don't need gamma to find B. So if you made a mistake with gamma, you could still get B right, but you would get C wrong. All right? All All right, so when you use the law of sines, you want to look for a row in the table that has everything in it. That's the most important row, okay? And you're going to use that row a lot. Okay, which row here has both pieces of information in it? The first, the second, or the third? Yeah, the first. Okay, so I'm going to take that first row, and I'm going to plug that into the first part of my law of sines. Sine of alpha over A. Okay, so we've got sine of 20 over 4. Okay, and this work that I'm doing right now, this is to solve for B. So if I'm going to solve for B, then I definitely have to use the information now in the second row. Okay, so now I'm going to use the B, and I'm going to use beta, and I'm going to fill in to this part. So I'm going to take what I just wrote and put equals sine beta over B. Sine, what's beta? 60 over B. Okay, does anybody remember what you call this kind of thing? The way we solve it is to cross multiply. This is begins with a P. This is a proportion. Okay, and that was my next question. How do you solve a proportion? You cross multiply. So 4 sine 60 equals B sine 20. Don't worry about typing anything into the calculator till the very last step. Okay. How would I get B by itself? How would I move sine 20? Divide each side by sine 20. And sine 20. Okay, that's B. And now we do need to type that in. Okay, but don't type anything in until the very, very last step. Okay, all these problems in this section are in degrees, so make sure you put your calculator in degrees. Okay, so that's the numerator, divided by sine 20. So 10 point will go to 3 places, 128. 10.128. Now I have 2 rows in that table that are complete, so I could use either one. Which one, though, do you think I'm going to use to find C? I'm going to stick with the first one. Okay, 2 reasons. 1, even if B is right, it's an estimate. And 2, even worse, B could just be wrong. Okay, so try to avoid using things you calculated if you can. All right. So now we'll solve for C. Okay, set up our proportion. Sine of 20 over 4. We're going to use that row again. And what's going to go on the other side this time? Sine of 100 over C. Okay, and after a while, when you do a lot of cross multiplying, you get to see the pattern. C is going to be 4 times the sine of 100. And then you're going to have to divide by sine 20. Okay, if you don't want to use that shortcut, you can do it out every time, but that's what's going to happen. 4 sine 100, and then you're going to have to divide by sine 20. Okay, any question on that one? Okay, now just type it in and round it off. 4 sine 100. Divide by sine 20. 11.518. Okay, quick thing you can check. Make sure the biggest side is across from the biggest angle. Smallest side should be with the smallest angle. If that doesn't happen, something is definitely wrong. Okay, and if you add up any 2 sides, they should be bigger than the third. So 4 plus 10 is bigger than C. 10 plus 11 is bigger than 4. And 11 plus 4 is bigger than 10. If you add up two sides and they're smaller than the third, then again, something is really wrong. Okay, so that's your side angle type. Okay, second type, which is pretty much the same process. Okay, which type is this one? Angle, side angle. You know two angles, and this time you know the side connecting them. Okay, let's set up our table, and then we'll see which row has everything in it. So A we don't know. B we don't know. But I know the side across from gamma is C. And C is 4. Do I know alpha? Yep, alpha is across from A. Okay, do I know beta? Yep, it's B, across from B, so that's 40. And gamma, we don't know. Now, I said to use the law of signs, you have to have a row in this table that's complete. Okay? Maybe you can see why side, side, side wouldn't work with law of signs. If you knew all the sides, you wouldn't have a row that's complete. Okay? So you either need to be given a row that's complete, or you can find one that's complete. Find something to make it complete. Can we find something here to make a row complete? Yeah, what can we find? We can find gamma. 180 minus 45 minus 40. Okay, so gamma is 95. Now, in this kind of problem, what we just did, that's a very important number. We're going to use 95 to find B, and we're going to use it to find A. So what that means is if we get gamma wrong, what happens? The whole thing's wrong. Okay, so this is a problem where if you make a mistake on gamma, it's all wrong. Okay, any question on gamma? Okay, so we're going to set it up. Anybody tell me what I would put on the left? Sine of, so you're going to solve for B? That's fine. So sine of 40 over B. And what about on the right?
95 over 4.
Yep, sine of 95 over 4. When you set up your proportion, it can only have one letter. So if you accidentally have two letters, then something's not right. Okay, so I'm just going to write how you would find B, and I'll leave plugging it in for you. 4 sine 40 divided by sine 95. Okay, can anybody tell me my proportion to solve for A?
45 over 8.
Sine of 45 over A, yep, I like it, equals 95 over 4, cross multiply, 4 sine 45, divided by sine 95. So these problems can be a little repetitive. You do the same calculations a lot. Just type those in, round them off, and those would be your answers. Okay. Any question on that one? Okay, so very, very similar. The only difference is you got to be very careful when you find gamma, because in this case you use it for everything. Right, and last problem, last type. Okay, this is the type where they give you two sides and an angle. And you'll see why this is true in a second. When you have this type and only this type, you could end up just being a normal problem, and you get one answer, just like we've been getting. Or you could get two answers for everything. Or the opposite, it's possible you get no solution. Okay, two solutions isn't harder, it's longer. You have to do every calculation twice. No solution is the easiest because you start to solve it, you type something in the calculator and it says error, and you're done. One solution is right in the middle. It's the type of problems you guys just did. All right, so let's set up our table using what I have up above. A is 3, B is 2, alpha is 40. Now, sometimes when you do a law of sign problem, you have a choice. Okay, what do you want to find first? Okay, in the last problem, someone decided to do B first and A second. Well, you could have done it the other way around. You could have found A first and then found B second. In this problem, you have no choices. There's something here you have to find first. Okay. We've got B.
I mean beta.
We got to find beta.
And
Okay. This last row, you need to ignore it right now because it's missing everything. If a row is missing everything, you can't use it. You have to use two rows, and you can only be missing one thing. So we're going to use row 1. We have to use row 2. There's no choices. All right. So we've got proportion. Okay. What can I put on the left? Sine of
40 over 3.
Sure. Sine of 40 over 3 equals sine of beta over 2. Now, what's different about this problem, since you don't have two angles, you can't just add up two angles and get the third one like we've done. Okay? We're going to be able to get an angle, but not by adding and subtracting from 180. Not for this one. Okay, well, let's cross multiply. 2 sine 40 equals 3 sine beta. And how would I get the 3 on the other side?
Divide by 3.
Yeah, so I'm just going to go like this. Divide by 3. And now we've got a situation we've seen before.
Or
I want to get rid of sine.
inverse of
I'm going to use inverse sine. On the right and on the left. So all of that gets plugged into inverse sine. And no, on the left, the sine and the inverse sine don't cancel because there's so much other stuff. Okay? You just have to type it all in the way it is. Okay, so let's see what we get for beta. Got the inverse sine of 2 sine 40. It's very important you close your parenthesis here because I'm about to type in divide by 3. If I don't close my parenthesis, it's going to do 40 divided by 3 and take the sine of that number. That's not what I want. So type it in just like that. Inverse sine of 2 sine 40 over 3. Now, this isn't a no solution problem. If it was no solution, it would say error right now. Okay? That is definitely a solution. 25.374. And I'm writing it higher in the box on purpose. Okay? We just did inverse sine. What quadrant is that answer in? 25.374. First one. Is there any other quadrant where sine equals a positive number? Quadrant 2. So what do I do with my reference angle to get the second answer in quadrant 2? Do what with it, Jamie?
180.
That's for quadrant 3.
180.
Subtract that from 180. 180 minus my reference angle. I'm not going to write that answer down in the box yet. I'm saying if there's a second answer, that's what it is. If it works. Okay? 154.626. Okay? The way we figure out if it works is look at the answer that you just got. Look at the original angle that was given. Could both of those angles fit in a triangle? Why not? It would be over 180. Okay? So the original angle was 40. This is 154. If you add them up, that's 194. In this case, the second answer is too big. So we ignore it, and now we finish the problem just like normal. If the second answer had worked, we would have written it in this box. Suppose the second answer was 100. Then it would have worked. Then we'd have two answers here, two answers here, and two answers here. It's like we'd be solving two different problems. All right? Now that I know beta and I know alpha, what can I find next? Now I can definitely find gamma. Just add these up and subtract from 180. So that's 65.374. Couldn't get gamma till you got beta. 114.626. And now that I have gamma, what can I find? Now I can find C. I couldn't find C because I didn't have anything in that row. So you're going to do sine 114.626 over C. And then go back to the original row where everything was given. Equals sine 40 over 3. Okay, cross multiply, and then you'll have your answer. 3 sine 114.626 over sine 40. Okay. So on the test tomorrow, you'll see one of each of these types. Okay? We didn't focus too much on the two solution case, so I wouldn't worry as much about that for tomorrow. I would focus more on the one solution case. All right, so the homework, it's mostly in the book, but there's two other ones I added. I'd like you to try 5 through 8, 10 and 16, and solve these two triangles. Alpha is 70, beta is 60, C is 4. And then another one, alpha is 45, beta is 40, C is 5. The book doesn't have any problems with two angles and a side in this section. Okay, that's why I made these up. Okay, so I'll be after school today if anybody needs extra help. And we'll go over these before the test tomorrow.